All right, today we want to look at some formulas in mensuration circles. First of all, let us look at our circle here. So this is our circle with center O. Now, in circles, any line from the center to any part of the circumference is called radius, and they are all equal. So we have OB equal to OA equal to OC equal to OD, and we call it radius, represented by small r. We also have a line AB. Line AB, we can say that it passes through the center of the circle, which means it divides the circle into two equal parts. So line AB is called diameter, all right, and it's represented by small d, as we can see it here. So diameter is a line that divides the circle into two equal parts. All right, there is a relationship between the diameter of a circle and the radius. As we can see, from A to O is R, O to B is R, and this is a straight line. So we can say R plus R should be equal to AB. So we can say our diameter is equal to R plus R, which will give us 2R. So D is equal to 2R, and R is equal to D divided by 2, which means if a question is given and diameter is given, you can get your radius by dividing your diameter by 2, and it will give you the radius. If the radius is also given and you need the diameter, you multiply the radius by 2, and that will give you the diameter, as we can see. Now, in circles, we have a constant number called pi, which is given as 22 over 7, or approximately 3.142. So if a question is given, pi is constant, it will be given to you to do your calculation. All right, let us look at the circle here. Now, the distance around the circle, which we can also call it perimeter, we can also call it circumference of a circle. That's the distance around the whole circle. Mathematically, is given as 2 pi r, or we can say pi d. But in these studies, our formulas are all going to be in radius, not in diameter. So you see everything in radius. All right. A circle has an area. So let us see how we can find the area of a circle. So area of a circle mathematically is given as pi r squared. So anytime they ask you to find area of a circle, your pi multiplied by your radius scale, your radius square will give you the area of the circle. Now, the diameter divides the circle into two equal parts called semicircle. All right. So you can be asked also to find the area of a semicircle. And the area of a semicircle, how do you get it? You just multiply the area of the circle by half. So in formula wise, we say 1 over 2 multiplying pi r square, which can also be equal to pi r square, or divided by 2, will give us the area of the semicircle. Now, when we look at this diagram, this shaded portion here is called quadrant in circles. They can also ask you to find the area of this shaded portion, which is the quadrant, and it's 1/4, because we've shaded this part. We have 1, 2, 3, 4. So we say it's 1/4 the area of the circle. As we can see it here, area of quadrant is equal to 1 over 4 times pi r squared. All right, let us also look at sector of a circle. Now, we have a line from the center to the circumference, which is A. Another line from the center of the circumference, which is B. Now, we have a portion here, and we have another portion here. This portion here, as we can see here, is called minor sector, because that's the smaller part of the sector. So we call it minor sector. And this bigger portion, we call it major sector. Now, if we represent the angle here by theta, all right? If we represent the angle here by theta, Then we can also say the reflex angle here will be 360 minus theta. So we need to know the difference between this angle and the reflex angle here. Now we can be asked to find the area of the minor sector, which means this portion. And when we have been asked, the formula we are going to use is our angle here, which is theta, all over 360 times pi r squared. So this is the formula we can use to find area of minor sector. We can also be asked to find the area of the major sector, which is this portion, this shaded portion here. All right. And we need the reflex angle here, which is the 360 minus theta. So the formula is given as 360 minus theta all over 360 times pi r squared. So this is the formula we can use to get the area of the major sector. All right. We can also be asked to find the length of this arc here, that is from A to B, and we can also call it minor arc, length of minor arc. How do we get the length of the minor arc? The length of the minor arc is given as the angle here, all right, which is the theta, over 360 times 2 pi r. So we can also have our formula for length of minor arc here. We can also be asked to find the length of the major arc, that is this bigger arc. All right. And in that case, we need our reflex angle here. So it's going to be 360 minus theta all over 360 times 2 pi r. So this is how we can find the two arc as we see here. We can also be asked to find the perimeter, all right? Perimeter of minor sector. That's the distance around the minor sector as we can see here, all right? And how can we get a distance? From A to O is radius, O to B is radius, and A to B is the length of the minor arc. So the distance around this will be this plus this, which will give us 2r plus the length of the minor arc, which is theta over 360 times 2 pi r. So we need to keep this formula so that when question is given, we'll be able to apply it. The next thing is we can also be asked to find the perimeter of the major sector, as we can see it here. That is from here to here, from here to here, from here to here, the perimeter, which is going to be our radius here, plus this radius, plus the length of the major arc. So we are going to have 2r plus 360 minus theta all over 360 times 2 pi r. So this is the formula that we can use. All right, let us look at the sector that we can see here. When we come here, we have another line from this. Let us take this. Let us take this. We have another line from A to B, all right? And A to B, there's a space or a region beneath it. This shaded portion here, we call it minor segment, minor segment. And the bigger portion, that is above the chord, line AB, which is the chord, above the chord is called major segment. Therefore, we can be asked to find the area of the minor segment. And this minor segment is part of the minor sector, as we can see here. So for we to get the area of this shaded portion, we first of all find the area of the minor sector, all right? Find the area of the minor sector as we have the formula. Then we find the area of the triangle here, all right? The area of triangle AOB. Then we subtract the area of the triangle from the area of the minor sector. And that is the formula we have here. Area of minor segment is equal to the area of the whole minor sector, which is theta over 360 times pi r squared, minus the area of the triangle, which is half multiplying r squared sine theta. In other case, area of a triangle can also be given as half base times height. We can also use that formula to find the area of the triangle, all right? And the angle here, which is the theta, are the angle that is formed, the angle that is formed at the meeting point of the two radius as we can see it here. Now, we can also be asked to find the area of the major segment, that is the part above the chord. So we have a shaded portion here, all right? And don't forget that we are going to use the reflex angle here. So first of all, we need to find the area of the major sector. We find the area of the triangle, then we add the two together, and that will give us the area of the major segment. So we have the formula here. Area of major segment is equal to 360 minus theta all over 360 times pi r squared. And this gives us the area of the major sector, right? Area of the major sector, plus the area of the triangle, this isosceles triangle within the circle, which is plus half r squared sine theta. Don't forget, we can also use area of a triangle, half base times height, to also get the area of the triangle. All right. Now, we can also be asked to find the length of the chord, that is called AB, as you can see it here. So first of all, we can take the triangle AOB out and we can put it here as you can see. So from here to here, that is A to O, is radius. From O to B is also radius, all right? And basically, this triangle is what? An isosceles triangle. Now, for we to find the length of the chord AB, which we can see the AB here. First of all, you divide your triangle into two equal parts, into two. And anytime you divide a triangle into two equal parts, because this triangle is an isosceles triangle, the angle here will be divided into two. So if the angle here, let's say, is 80, half, which will be 40, 40, all right? And again, because this triangle is an isosceles triangle, anytime you take your height, the baseline will be divided into two. So what we are going to do is that we first of all find half of the baseline, let's say NB. Then when we get half of the baseline, let's say NB, then we multiply it by 2, and that will give us from here to here. Because from here to here is also the same as from here to here. So find half of it and multiply it by 2. And how do we find half of it? So we can consider triangle NOB as we have it here, NOB. Our angle here will be given, all right? And we can represent it by alpha. We are from O to B, which is the radius, and we are looking for what? NB. So we are going to use our trig ratios. If you can remember our acronym, SOHCAHTOA. All right. So by here, we have the radius and we are looking for this part, which is opposite. So anywhere we have the radius, which is the hypotenuse, and our NB is opposite. So you are dealing with hypotenuse and what? Opposite, which we are going to use our sine ratio. So how do we use it? We say sine alpha, which is the angle here, all right? Sine alpha is equal to opposite over what? Hypotenuse, which is NB over what? Our radius. Don't forget, we are looking for NB. So we use our radius to multiply, that is sine alpha. So we have NB equal to R times sine alpha, all right, as we can see it here. And when we use our radius to multiply sine alpha, that will give us NB. And we are looking for AB. So after we using our R, which is the radius, to multiply sine the angle, whatever you get, you multiply it by 2. And that will give you AB, which is the length of the chord. So we need to study these formulas. Then in our next chapter, we are going to see how we can use these formulas to solve questions. Thank you.